In this video, we want to look at a very special exponential function, the exponential function e to the x. So this number e is a special number for us. This number e is the base that makes the limit as h goes to 0 of b to the h minus 1 divided by h equal to 1. In other words, e is that number such that the limit as h goes to 0 of e to the h minus 1 over h is equal to 1. Okay, so this number e is approximately equal to 2.718, and it starts to kind of go on forever, and this is an irrational number. An irrational number just means it can't be written as a quotient of two integers. Okay, so I've placed the graph of e to the x over here in green. We just decided to create a little xy table, and I hope you guys can see that when I insert a 1 in for e, I get that 2.718 here. And we can see that because 2.718 is greater than 1, our graph is going to have this increasing curve shape. So it's like the 2 to the x graph that we had looked at earlier. Okay, so let's use this graph to calculate a few limits. When we look at example 2a, and I look at the numerator is e to the 2x, the denominator is e to the 2x plus 1, but we're taking a limit as x goes to infinity. So I hope that we can see when we plug infinity into the exponent, 2 times infinity is just going to be infinity. When I look at the graph of e to the x as we go to infinity, this graph looks like it's going to go to positive infinity as well. So the numerator, to me, it looks like it's going to some sort of infinity. The denominator is also basically going to be infinity plus 1. This is also some sort of infinity. So we basically get this infinity over infinity. I don't really know what that is. So the way that we're going to calculate this limit is we're going to change the way it looks algebraically. So we're going to multiply top and bottom by 1 over the highest term in the denominator. So in this particular case, the highest term in the denominator is that e to the 2x. So we're going to multiply top and bottom by 1 over e to the 2x. And when we do that, we will get the following. We're going to get the limit as x goes to infinity. The numerator is just going to be 1. We need to distribute the denominator, so that's going to be, when I distribute this across the addition, the e to the 2x divided by e to the 2x, that's going to give me a 1. But then for the second term, the 1 over e to the 2x times 1, that's going to give me a 1 over e to the 2x. Now, I want to look more carefully at this term right there. So let's discuss that guy. Now, the numerator is constant, but the denominator is getting very large, right? I mean, that bottom is going to infinity. So when you have the numerator is constant and the denominator is getting very large, that whole thing is going to go to 0. So this part goes to 0. So in the end, I am going to have 1 over 1 plus 0, and that's just going to give me the answer of 1. So the answer for 2a is just going to be 1. Let's take a look at 2b now. 2b looks pretty similar. When I plug in infinity in for e to the 2x into e to the 2x, the numerator is still going to be infinity. The bottom is going to be infinity minus 1. Infinity minus 1 is still infinity, right? If you took a very large number and you subtracted 1, basically nothing happens. So we get infinity over infinity again. So in this particular case, I'm basically going to do the same exact thing I did last time. I'm going to multiply top and bottom by the highest power, the reciprocal of the highest term in the denominator. So this will be the limit as x goes to infinity. You're going to have a e to the 2x over a e to the 2x minus 1 this time. Effectively, this question is pretty much the same as the previous one. We're going to multiply top and bottom by 1 over the highest term in the denominator. So the highest term in the denominator is e to the 2x. And when I do that, I am going to get the limit as x goes to infinity. The numerator is 1. The denominator is going to be 1 minus 1 over e to the 2x, like this. As we saw earlier, that 1 over e to the 2x, this part is going to go to 0. So yet again, I am left with 1 over 1 minus 0, which is 1. So the answer for both example 2a and example 2b is 1. Okay, let's take a look at our third and most exciting example right here. In this particular example, I'm taking the limit as x goes to 0 now. So this situation is a little bit different. And what happens when I attempt to substitute in a 0 into this limit? Well, substituting a 0 into the numerator is going to give me e to the 0, which is 1. And when I substitute 0 into the denominator, I'm going to get e to the 0 minus 1, which is 1 minus 1. So really, effectively, I get that this thing is 1 divided by 0. So when you've seen something like this in the past, this situation is what we call an infinite limit, right? And the question becomes, is there any way that I can simplify this object to eliminate the 0 in the bottom? And if there is no way, that's when you have the infinite limit right here. So I don't see any cancellation that I can do because of the subtraction right here. So whenever we're investigating infinite limits, you really want to, we need to investigate the two one-sided limits. Okay, we know it's going to go to some sort of infinity, but does our picture look more like this? Is it more like, let's say here's 0. Does it more kind of blow up like this? Because if it blew up like this, then the limit would be equal to positive infinity. Or does it more blow up like this? If you came from either side, then this limit would be equal to negative infinity. But another scenario is if it looks like this. So let's say this side blows up and this side blows up, but in the opposite direction. So from the left, we get positive infinity, and from the right, we get negative infinity. Or conversely, let's say you got, here's 0. From the left, you get negative infinity, and from the right, you get positive infinity. So in each of those cases, we would say the limit. We would say the limit does not exist. So I write that as D and E like this. Okay. So we just got to figure out, which situation we're in with this part C. So let's do that now. Let's figure that out. So we're going to calculate two one-sided limits. We're going to take the limit as x approaches 0 from the negative side of e to the 2x divided by e to the 2x minus 1. And then we're going to also come from the positive side. So we're going to use the same trick we've been doing before. We multiply top and bottom by 1 over the highest term in the denominator. So in this case, it's again e to the 2x. And after I do my distribution, I get the limit as x goes to 0 from the negative side. We're going to have a 1 over here. We're going to have a 1 over here. And we're going to have a 1 over e to the 2x in the denominator. And at this point, it really becomes important to look at this term right here. And we're trying to understand what is going on. So because we're coming from the left side, we're plugging in numbers that are a little bit less than 1. So if we go all the way back to our graph of E, when we're coming from the left side of 0, I hope that you can see that we're really getting values that are a little bit less than 1. And this is going to be the same even if we replace the e to the x with e to the 2x. That graph is still going to, when you're coming from the left of 0, you're still getting numbers that are less than 1. So really, the type of thing that we're getting here, we're getting something like, this part here is something like 1 over 0.999. Okay. So when I look at that, this number right here is actually, this number is bigger than 1. Okay. So we're going to have 1 divided by 1 minus a number bigger than 1. And the central thing that we're concerned with, we know it's going to be some sort of infinity. We're worried about the sign. So the numerator is going to be positive because 1 is a positive number. The denominator is going to be 1 minus a number that's bigger than 1, so that denominator is going to be negative. So this tells us that our limit is going to be negative infinity. Okay, and that's when we come from the left side. Let's take a look and see what happens when I come from the right. So now I'm going to take the limit as x goes to 0 from the positive side, e to the 2x over e to the 2x minus 1. Just as before, I multiply top and bottom by 1 over the highest term in the denominator. And just like before, I'm going to get the limit as x goes to 0 from the positive side of 1 over 1 minus 1 over e to the 2x. Now I'm looking at the same term, but this time I'm coming from the right side of 0. So when I come from the right side of 0, this part right here is really 1 over 1.001, something like that. We're plugging in numbers that are a little bit, plugging in numbers to the right of 0. So when you look at that whole fraction is less than 1. Again, we're really concerned about the sign of this thing. So when I take a look at the sign, what am I going to get? The numerator is going to be positive because 1 is a positive number. But the denominator, what's the denominator going to be? It's going to be 1 minus a number that's less than 1. So a number that's less than 1 is just going to be 1 minus a number less than 1 is also positive. So this tells us that we're going to get a positive infinity. All right. So let's piece this all together. So when I come from the left, I get negative infinity. When I come from the right, I get positive infinity. If I were to put these two things together, what would that mean? That would mean you come from the left, you get negative infinity. You come from the right, you get positive infinity like this. I think the limit does not exist. So that's going to be our final answer. The limit as x goes to 0 of 2e to the 2x divided by e to the 2x minus 1 does not exist. All right, everybody. This concludes our video about the exponential function e to the x. Take care.